Hello everyone, my name is Schnieder and I'm a research fellow at ARU in Cambridge. Today I would like to present the results of a systematic literature review which I conducted recently. The systematic literature review focuses on an innovative way to deliver parcels in cities. This review focuses on all the new technologies you might have heard about, from delivery by drones or autonomous delivery robots to delivery by public transport or underground delivery systems. UAVs, commonly known as drones, are expanding the capabilities of various industries, from military operations to civilian use cases such as infrastructure inspection and the film industry. With the recent advancements in technology, drones have also captured the attention of last-mile delivery companies. Commonly cited advantages of using drones are the ability to deliver parcels faster due to not being subjected to road traffic, as well as the ability to fly in straight lines. In addition to the technical development of drones, strategies to mitigate the risk of drones have been researched. Examples include the ground mapping of risks, an evaluation of the environmental risks drones are exposed to, such as rain, wind, signal strength, and birds. Ideas to mitigate accidents have been proposed, such as a guided emergency recovery system, collision avoidance algorithms. Cybersecurity and cyber attacks form another research focus. From an operational viewpoint, scholars have investigated the use of shared or dedicated facilities for drones, how to integrate drones into existing airspace, the battery management and routing problems, as well as navigation and pathfinding. Finding a suitable space to land drones continues to be a challenge. To solve this problem, research into dedicated departure and landing zones has emerged. The space for such may not always be available. Therefore, options without dedicated landing facilities are also investigated, such as dropping off parcels on the roof of passenger vehicles, a robotic arm that catches drones mid-air, or a cable attached to the drone to suspend parcels. Combining drones with land-based vehicles, such as trucks, in a delivery model is often seen as an option to mitigate the limitations of drones. Some initial research has also been conducted on combining drones with public transport, where drones are hitching a ride on public transport vehicles. Autonomous delivery systems stand at the forefront of transformative innovations in logistics and transportation. However, the realization of fully autonomous delivery systems is not without challenges, and some technical hurdles still need to be overcome. A lot of research has focused on surveys to understand the user acceptance of ADRs. They have also investigated possible ways to interact with ADRs, as well as the willingness of enterprises to include ADRs in their last-mile delivery operations. There are various technical challenges that need solving, including navigation, localization, path planning and obstacle avoidance, prediction of pedestrian intentions, indoor routing, as well as ways for robots to learn from each other to avoid obstacles. As for drones, secure wireless communication as well as customer authentications are common issues. Robots come with similar limitations as drones, and therefore combining trucks with robots has been proposed as well. This allows especially smaller robots that have a short range and slow speed to operate the last mile in hopefully quieter residential neighborhoods, reducing the need to navigate main roads or urban highways. Similar to drones hitching a ride on public transport vehicles to recharge or travel longer distances without requiring their own resources, robots may be able to take public transport whenever there is sufficient capacity available. Autonomous trailers have also been proposed. Instead of driving a larger truck around the city to carry all parcels, a smaller vehicle with a trailer could be used. The autonomous trailer can then be left at a drop-off point while the delivery van continues with the deliveries until the trailer is picked up again. Another option is autonomous vehicle-assisted delivery. Instead of delivery vans being parked and drivers returning to them after dropping off some parcels, the delivery van could follow the driver around, or pick the driver up at another location, reducing the need for the driver to return back to the van. City depots are essentially smaller facilities where parcels can be moved from one vehicle to another one. By splitting the delivery into two parts, vehicles that would not be able to complete all aspects of the delivery can be used. For example, larger trucks or large drones are not suitable for delivery within residential areas, but these can be used to transport parcels to the city depot. Other vehicles, which may have limited range or slow speed, but are most suitable for delivery in residential areas, such as cargo bicycles, pedestrian couriers, and small drones, are used to transport the parcels from the city depot to the customer. There's a wide range of shapes of these city depots. These city depots can either be fixed locations or mobile meeting points. Cities may only have one larger city hub from which all local deliveries are performed, or a set of small micro-depots are spread across the city. The size of these city depots can range from a warehouse with sorting facilities to just a nano-hub, which can be as small as 1 to 3 parking spaces. While the delivery company may operate their own set of city depots, having shared city depots would allow delivery companies to consolidate their shipments by delivering these to the city depots themselves and use a shared fleet to deliver the parcels from the city depot to the customers. Due to the variety of city depot types, there is a vast number of synonyms used in the literature: localized storage depot, micro-depot, transshipment facility, and so on. Crowdshipping has emerged as the solution within the last-mile delivery domain. It capitalizes on the collaborative power of crowdsourced networks to facilitate efficient and effective parcel transportation. This concept harnesses the unused capacity of individuals' travel routes to match senders with travelers heading towards the intended delivery destination. This creates a decentralized and dynamic delivery ecosystem. There are essentially two different spectrums of crowdshipping based on the additional mileage required to deliver the parcels. At the one end, casually employed delivery personnel transports the parcels in a similar fashion to a traditional employed delivery driver. On the other end, there are public transport users who transport parcels from one stop to another along their normal commuting pattern, without doing any detours from their normal commute. In the middle there are people who drop off parcels along their daily commute with only minimal detour. Pedestrian couriers, commonly referred to as porters, are a traditional, yet innovative, method of last-mile delivery. Porters contribute to sustainable and efficient delivery by minimizing the environmental impact. They offer a zero-emission alternative to motorized vehicles and reduce the congestion and pollution in urban settings. The absence of vehicle noise contributes also to quieter and more livable urban spaces. Given that delivery vans spend considerable amount of time being stationary, it is not surprising that researchers have investigated the usefulness of pedestrian porters. Another major research theme are parcel lockers or collection and delivery points. Parcel lockers are secure, self-service storage units commonly used in the last-mile delivery process to temporarily house and facilitate the collection or delivery of packages. These lockers are often installed at convenient locations like residential complexes, retail centers, or public spaces. They are points for recipients to retrieve their parcels at their convenience. Parcel lockers contribute significantly to efficient last-mile delivery by minimizing parcels theft or damage, minimizing missed deliveries, while accommodating the busy schedule of recipients. The scope of the literature includes surveys and choice models, the location and optimization of parcel lockers, modular parcel lockers or mobile parcel lockers, as well as comparing parcel locker delivery with home delivery. As neither home delivery nor collection and delivery points nor lockers may always be the most desirable solution, researchers have investigated alternative options to deliver parcels. From a routing perspective, it is possible to use the delivery vehicle as a base from where the driver is walking to various customers on foot, instead of driving close in front of each drop-off point. Multiple drop-off locations for each customer can also be an option to extend the opportunities for a successful delivery. Some researchers go even further by suggesting roaming delivery locations such as car booths. Also, more traditional methods are investigated, such as reception boxes, which are a secure place to drop off parcels at the customer's house. Failed deliveries could also be avoided by predicting the customer's availability by using data gathered from IoT devices or an availability profile determined based on historic successful deliveries. Flexible delivery dates allow more freedom for operators to optimize their delivery tours and therefore may reduce costs. Alternatively, nighttime delivery is an option to mitigate some of the concerns caused by traditional delivery methods. Curbside usage is a major problem for last-mile delivery operations. Scholars have suggested to reduce cruising for parking by providing real-time curb availability information data to drivers, by allocating loading bays. As many delivery drivers serve multiple customers per stop, a driver helper has been suggested to shorten the dwell time of delivery vehicles. Not just drones and autonomous delivery robots can take advantage of public transport, also normal delivery can be combined with public transport. Various names have emerged for this type of last-mile delivery: multimodal passenger and package sharing network, cargo tram, co-modality system, collaborative urban public transport system, and so on. These parcels can either be transported on existing public transport lines or on ride-sharing vehicles, or on autonomous vehicles transporting both passengers and parcels simultaneously. Due to the space in cities being rather limited, underground logistics systems have been proposed as a solution. These underground logistics systems typically involve a network of tunnels or dedicated pathways designed for autonomous vehicles. Scholars have evaluated the external benefits of such a system, as well as the effect on traffic, as well as emissions. Electric bicycles and cargo bicycles play a key role in sustainable and efficient last-mile delivery solutions. Cargo bicycles are specifically designed to carry larger goods or cargo. Both bicycles and cargo bicycles are well suited for transporting packages, groceries, or various other items in urban environments. They not only bypass congestion and access narrow and residential spaces more easily, they are also considered to be a more environmentally friendly transportation alternative. Many researchers have conducted surveys and interviews to gain an understanding of the consumer perception of cargo bicycles, the drivers and barriers of the adoption, and the willingness to pay for different sustainable delivery options. A few routing algorithms have also been proposed, which consider the peculiarities of cargo bicycles, such as load-dependent travel speeds and parking issues. Various evaluations have been conducted to, for example, gain a better understanding of the delivery tours with cargo bicycles and the impact of environmental factors such as weather and hilliness. Electric vehicles have emerged as a solution for last-mile delivery. Many studies focus on routing of electric vehicles, as well as the charging location problem. The limited range of electric vehicles and charging needs adds a layer of complexity to the delivery operations. The aim of these studies include combining the charging station location and the routing problem into one, routing with battery swapping, routing with swapping and charging combined, as well as the advantages of partial recharging. Additional revenue streams from vehicle-to-grid integration has also been studied. Scholars have also focused on the use of digital twins in last-mile delivery, from the development of such to an evaluation of their usefulness to policymakers. Quantum computing and Industry 4.0 technologies have been suggested to support last-mile delivery operations. The use of motorcycles, e-trikes, and even e-scooters as delivery vehicles has been suggested in the literature. I hope this overview of recent innovations in last-mile delivery has been useful for you. Thank you for your attention.